Bueno, la charla está toda escrita en inglés, pero voy a hablar en español porque evidentemente todos acá hablan en español. Mi nombre es Party, soy arquitecto en Wonderland, arquitecto no de edificios, arquitecto de código. Para los que no conocen, en Wonderland lo que hacemos es trabajar con varios partners de Web3, tratando de construir el futuro Web3. Dentro de estos partners nos tocó trabajar primero con Connext, que hoy es Everclear. Ahí empezamos a ganar experiencia en todo lo que es el mundo de cross-chain. Después trabajamos con Optimism. Con Optimism hicimos los contratos principales de interoperabilidad para la superchain. Y ahora estamos trabajando con Ethereum Foundation, tratando de coordinar los distintos estándares que existen para interoperabilidad. ¿Bien? Entonces, la idea de esta charla es dar un poco un pantallazo general, abrir un poco lo que es el Summit. Y nada. Quería empezar con una pregunta, que es ¿cuántos de acá saben o creen saber lo que es interoperabilidad o a qué nos referimos cuando hablamos de interoperabilidad? Ok, entonces va a ser un tema bastante nuevo para la mayoría. La idea de hoy es que haya un poco de contenido para aquellos que no saben absolutamente nada de interoperabilidad, que se lleven algo, y para aquellos que sí saben, que también puedan profundizar un poco. Si en algún momento ven que se vuelve muy técnico, no pasa nada, después me pueden preguntar o lo que quieran, y podemos seguir charlando. ¿Sí? Bueno, se ve que tiene un alcance cortito. Ahí está. Bueno, la charla es bastante straightforward. Voy a tratar de explicar primero por qué estamos hablando de Interop, segundo, qué es Interop, o tratar de definirlo, después, cómo vamos a conseguir interoperabilidad, y por último, qué sigue. Bueno, ¿por qué estamos hablando de interoperabilidad? Arranquemos por tesis muy básicas. Hay una tesis muy fuerte, que es muy obvia también, que es que queremos escalar. La cantidad de transacciones que hoy en día se procesan no son suficientes para que cripto sea como la plataforma donde ocurran todas las transacciones. Visa tiene 50.000 transacciones por segundo o 60.000 en sus picos y en Ethereum tenemos del orden de 20. ¿Okay? Obviamente que eso ya fue mejorando, ya tenemos varias cosas que lo hicieron mucho más piola, pero bueno, estamos muy lejos todavía. ¿Bien? Pero ¿cómo escalamos? Tenemos un camino que es el de escalar monolíticamente, pero un poco la tesis que tiene Ethereum hace un tiempo, que es que no es posible escalar monolíticamente. Cuando me refiero a escalar monolíticamente es convertir Ethereum en una mega computadora que hace todo y que puede hacer un millón de cosas. Acá, perdón para los de Solana, porque Solana un poco intenta ir por esta vía. Hay dos motivos por los cuales es muy complejo. El primero son temas técnicos. Si yo quisiera tener una blockchain que puede procesar 60.000 transacciones por segundo, lo que va a terminar pasando es que se vuelve o requiera un hardware muy potente para poder procesar todo eso. Eso lo que termina pasando es que necesito mucha plata para correr ese hardware, es muy costoso correr un validador, tengo pocos validadores, se vuelve centralizado y se pierde un poco la gracia, ¿no? La idea de hacer todo esto es que sea descentralizado, si no usamos Visa. Entonces, bueno, ese sería el primer desafío. El segundo motivo por el cual es complejo, que no es menor, es complejidad social. Parece una estupidez, pero las blockchains al final del día están gobernadas, o sea, tienen alguien que toma la decisión de hacer un upgrade y no otro, de hacer tal cambio y no otro, y anda a decir la Visa que todas sus transacciones están sujetas a las decisiones que toma por ahí 10 tipos de Ethereum que no tienen nada que ver. Entonces, bueno, es por ese motivo que empezamos como a separar cómo funcionan las blockchains y empezar a decir, bueno, en vez de tener todo absolutamente en el mismo lugar, todo lo que es ejecución, todo lo que es consenso, la data, todo, separémosla y tratemos de hacer cosas que sean más modulares. Y de esa forma vamos a poder escalar un poco más ordenadamente. Esa es un poco la tesis que viene teniendo Ethereum. Todos los upgrades que vende Ethereum son básicamente ir hacia este tipo de modularización, ir mejorando para que cada una de las cosas funcione un poco más mejor. Bueno, entonces, así es como empezaron los rollups. Los rollups son como, bueno, cuando hablamos de Ethereum hablamos de una virtual machine. Los rollups serían como virtual machine que se construyen arriba de la virtual machine, que parece una estupidez, no suena muy bien, pero está bastante piola porque lo que te permite hacer es tener un montón de transacciones que uno procesa por fuera con un secuenciador o un agente que agarra, construye todas esas transacciones, muy centralizado, pero no te importa porque al final del día toda esa centralización después se postea en Ethereum y uno tiene como un montón de transacciones en Ethereum en una transacción que entró. Entonces es como si fuese una especie de compresión que uno hace de todas esas transacciones que le permite tener mucha más escalabilidad. Esto está muy resumido y seguramente los que sepan un poco más del tema van a decir que está diciendo cualquier verdura, pero bueno, necesito que se entienda esta parte. Bueno, entonces hay muchas ventajas. La primera es escalabilidad, obviamente. Esto nos permite procesar muchísimas más transacciones, que los usuarios no tengan que pagar una guasada de gas. Pero además nos permite tener gobernanza especializada, porque los rollups tienen autonomía. Pueden hacer cosas como, sí, decidir a qué precio poner el gas o qué cosas quieren, qué upgrades quieren tomar, por más que estén sujetos a lo que pasa en el E1, porque después tienen que mandarse al E1, pero tienen mucha autonomía. También tecnología especializada. Estas rollups no tienen por qué ser copias de Ethereum, pueden ser muy customizables y pueden hacer, no sé, una rollup muy específica para hacer order books, una rollup muy específica para NFTs o lo que quieras. Y obviamente, como todo campo maduro, a medida que madura, se va especializando. Es natural que pase esto, es sano que pase esto, y la especialización genera como cosas más pro. Después, gas market diferenciado. Seguramente acá hay varios que están hace bastante tiempo en Ethereum y que pasaron por esa de tratar de swapear en Uniswap y pagar $80 por un swap, porque por ahí al lado estaban mintiendo NFTs. Bueno, eso no debería pasar. O sea, si vos esperás hacer un reemplazo con una plataforma de pago mundial como Visa, no puede ser que el que pague Visa te debe pagar más fee porque al lado están haciendo cualquier cosa. ¿Okay? Y por último, sequencer revenue, que parece una estupidez. Básicamente el sequencer revenue es lo siguiente. Yo les dije que está el sequencer, que es este actor que agarra las transacciones de los usuarios, crea los bloques y después de un tiempo los manda y los postea en Ethereum. Cuando hace esto, cobra por gas a los usuarios por sus transacciones y después gasta un poco para meterlo en Ethereum. Hay una diferencia entre lo que cobra y lo que gasta, entonces genera profit. Hay muchos protocolos que no tienen problema en cobrar plata, por ejemplo Uniswap o los lending, como que tienen formas de cobrarte un fee y te cobran por el servicio. Pero eso no es generalizable. Hay un montón de protocolos que si te cobran un fee, lo forquean y se van todos los usuarios al que es gratis. ¿Okay? Y es un problema muy grande que tiene la industria y por el cual un montón de empresas se fundieron. Entonces, esto a vos lo que te permite es tener una forma más orgánica de cobrarle a los usuarios sin que el usuario se dé cuenta de que le están cobrando, porque ahora en vez del usuario pagarle el gas al validador de Ethereum, se lo va a pagar a tu sequencer. Y es por esto que hay un montón de empresas como Coinbase, como Uniswap, como Sony, que de repente están interesadas en hacer este tipo de cosas, en tener su rollup. Hay un montón de rollups porque, bueno, ahora genero plata y está bueno generar plata. Bueno, pero no todo es color de rosas. Hay un problema muy grande que se genera con todo esto, que es la fragmentación. El hecho de tener un montón de distintas blockchains hace que cuando yo quiera ir a swapear, ahora en vez de tener un único mercado con muchísima liquidez, tengo toda la liquidez distribuida entre varias blockchains. Entonces cuando swapeo contra menos liquidez. Si swapeo contra menos liquidez, probablemente sepan, eso va a generar más impacto en el precio, porque un movimiento pequeño genera más impacto, y me llevo peor cambio. Entonces, el usuario se lleva peores cambios. Además, spoileé lo... Ahí está. Además, por ejemplo, si yo quiero interactuar con distintas aplicaciones, tengo que estar pensando en qué chain está la aplicación, y es una paja tener que estar bridgeando. Seguramente les pasó, quieren interactuar con algo, no tienen fondo del otro lado, tienen que bridgean USDC y se dan cuenta de que no tienen para pagar el gas, entonces tienen que ir y bridgear ETH y ya cerrás la computadora y decís, me quedo con Visa, ¿no? Entonces, bueno, justamente por esto es que surge Interop como una solución a esto. Decimos, bueno, queremos efectivamente este camino de los rollups como escalabilidad, pero no nos gusta que esté todo fragmentado. Interop es la forma que tenemos de tratar de arreglar ese problema que se genera. ¿Ok? Porque la otra es tirar la toalla y bueno, volver a hacer la escalación monolítica tipo Solana. Bueno, acabo de ver una definición de Interop, pero bueno, no sé si fue la más clara y no va a ser la más clara porque tampoco tengo idea, ni hay una definición clara. O sea, honestamente, nadie tiene una definición muy buena de Interop. Pero lo que venimos haciendo con la Ethereum Foundation... Yes, okay. So what we have been doing with the Ethereum Foundation is basically to coordinate on how to build Interop. And to do so, the first task we have tackled is trying to define the goals of interoperability. And we identified 3 goals. So the first one is trying to minimize the UX fragmentation. So the fact that whenever you want to interact with different applications, you need to be aware on what chain are you standing. You need to add the chain to MetaMask. You need to be switching chains. Your application will show you the balance only for the chain you are standing on. The application has no way of knowing which balance you have on other chains. So that's not how it should work. Like, you should have kind of the experience of a single account across all chains. You should feel like you are interacting with a black box in some sense. Like the wallet will tell you, yeah, whatever, I'm going to abstract away all the complexity. You just have one account, don't worry. And I'm not talking only about EVMs here, I'm also talking about things like Solana. Like Solana should also be integrated. You should have your account of Solana. Even if you have multiple addresses, which is something you sometimes do, you can have that abstracted away. The second goal is try to maximize the speed. This also happened to you if you have been using Ethereum for a while, that when you try to breach, you end up waiting for long times. There are many good solutions now that make this very fast, but the historical way in which we breach was extremely slow, all right? So maybe hours, maybe days, going to Discord and say, hey, my transaction got through, but I never got the funds, and then scammers trying to write you and say, hey, I'm gonna help you with your MetaMask. Well, so the goal will be that whenever you breach, why do we care about the speed? Like, there is a very famous study in Web2 saying that whenever users interact with the website, if the wait time is longer than 2 seconds, they tend to bounce off. There is like a 50% chance increase starting from 2 seconds that visitors just say whatever and they close the computer, okay? So we want to have the same. I don't know the year of the study. This is probably like at least 5 years old, so I don't know what's the attention span now after TikTok has been for some years. But yeah, we still want to aim for a fast, and 2 seconds is fast enough. So the second goal will be to have transaction being cross-chain, feel like you are on the same chain, extremely, and in particular, like below 2 seconds. And then the last goal is going to be to maximize simplicity. So now when users interact with an application, they have to declare exactly what they want to do. They say, I want to first approve this contract to use my funds, then you need to do a transfer maybe, and then you stake or whatever. This is not ideal. Like the user being aware exactly of the functions they are calling on a contract. Nah, that's not the way. The way in which it should happen is that users should say exactly what kind of result they want, and the app should handle what functions to call. So basically, users should not be knowing exactly what they are doing, and in particular for cross-chain, it's the same. Users should not even know that they are doing cross-chain applications. All right, so to recap, we have 3 goals. The first is to minimize UX fragmentation. We want one account across all chains. The second is to maximize speed. Transactions should feel like one chain. And the last one is maximize simplicity. So users shouldn't know they are breaching. Everything should be abstracted away. So one common question is whether or not interop is equal to bridges. The answer is no. For years, we have been talking about bridges and like as the technology of the futures. And now no one speaks about bridges. Everyone speaks about interop. So what happened? All right, so the thing is bridges is kind of the vision that is centered around the infrastructure, thinking about the message passing interface and all that. And we don't care about that. We just care about users having this seamless experience when going cross-chain. So users should not think about bridges, but we, as developers, will think about bridges a lot to build interop. All right, so how do we achieve interoperability? So first, regarding minimizing UX fragmentation. So this is an issue for apps and wallet. They should kind of abstract everything away. And we have a lot of work to do regarding standards and making wallets and apps know what to expect. Also, we need wallets that are interop aware. And here is some alpha. Like we at Wonderland have been asked by the Ethereum Foundation to start developing a wallet that is interop first. So trying to abstract everything away. So you're probably going to see a very fun experiment in some months about this. Regarding work on standards, we have also been working with the EF on standards for wallets and apps to understand how to tie an address on the chain, because users should not think about what address and what chain or whatever, but wallets need a clear way, and there is no standard now, so this is one of the things we're doing. There are other standards which are trying to solve also interesting problems, which is, for instance, when you interact with an application, the application has no way of knowing your balance cross-chain. They can only know the balance in the chain you are standing on. which doesn't make any sense, because if you want an application, for instance, that says send money here and you can pull from other chains, it has no way of doing so. So there are standards to kind of add those kinds of methods to the wallet. Regarding the second goal, how to maximize speed, what can we do? Well, this is kind of there are several angles of attack here. The first has to do with message passing. Message passing, I want to say it kind of very too long didn't read, but message passing is the following problem. I want to communicate between chain I and chain B. I want to send a message, but these are two separate computers. I have no way of bringing information from one place to another in a trustless manner. So how can I make sure in the target chain that the message that I'm receiving is actually the same message that was originated, and there wasn't like an eavesdropper that intercepted the message, changed it, and now is doing a different thing. So this is a huge problem, and this is what bridges are trying to solve, actually. So there are several ways to do this, but the problem is that we want to do this fast. And usually, speed is an enemy of security, because the faster you do things, the less time you have to verify or check. So there are two ways of doing fast message passing. The first one is trusting a third-party bridge. Here I'm talking about wormhole, layer 0, and all of those. But basically what they do is they see the messages and they attest, they have some way of checking those messages are valid, and then they say, hey, sure, this is okay, they sign it, and then you receive it on the other end. This is trusted in the sense that you trust the technology that they are building. Then you also have native interop, which is a consensus layer, which basically says that the messages are verified at the same level that the chain is being verified. And this is, for instance, what the superchain or Optimism is doing. So with Optimism, what we did was build the contracts that manage this exactly. So the idea is that in the superchain, you're going to have a set of sequences, so these agents that build the blocks, that are going to hear each other. They're going to hear each other, and whenever there is a message on one chain, that message is going to be able to be replicated on the others. So me as a user can say, hey, there is this valid message that I originated here, and the sequencer will check if that's true or not. If it's true, it will process the message, so you will have like this very fast, like 2-second message. If it's not, it's going to revert in the same way that if you want to send 3 Ether and you have 2 in your wallet, the network is going to say, no, dude, this is not valid. So the key here for fast message passing is that sequencers will trust each other. They will basically say, yeah, I trust this guy. This is true. OK, I'm going to include it. You might ask here, OK, but what happens if a sequencer lie? That can happen. And if a sequencer lie, that's not an issue, because a sequencer lie can be catched in Ethereum, because these are optimistic rollups. So there are methods to catch that and say, hey, this sequencer is lying. What happens in that case is that the chain will kind of go backwards. It will reorg, and it will go back to a state where there was no lie. So everything would be safe. So even if a sequencer lied, it's OK. It's going to be annoying because you're going to go back in time, but it's OK. Like funds are OK. But this you can only do if you make sequencers hear to each other, which is not something you can do for every single chain. So there is another solution that's been very popular lately, which is like using any kind of CK messaging or canonical message or any safe message that is very slow. We don't care here, and having solvers. So this is like a very key word that you're going to hear a lot today, probably. Solvers are people that basically see, people or bots, that see that you want to bridge fast. And what they're going to do is they're going to say, hey, this is my liquidity. Like they open their wallet, they say, hey, this is my money. Use this. You have this very fast. And I'm, as a sequencer, going to wait for the message to get there. When it gets, I'm going to recover the money that I lend you, plus a fee. So they are incentivized to do this. Of course, if a bridge has an issue, the one that gets the issue is the solver. But yeah, like this is one of the paths that, for instance, across Uniswap X are taking. LeFi is also working here. So it's something like this. Basically, Alice wants to bridge. The solver's here. They're gonna send the message very fast to the other chain, and after some time, they're gonna receive the money plus some fee. Okay. All right, but there is a second catch here because the solvers need the money actually to make the bridge. So that's an issue. You also need the liquidity. Even if the message passing is very fast, you need the liquidity. So how do we solve this? Well, there are not many workarounds. There is the traditional path, which is the most easy to generalize, to expand, which is basically to say to the solvers, hey, you should have money here and there and there and there and there and there. And if you run out of money, well, bad luck. You're missing a business. That's a path. That's possible, but it's, of course, limited. The second path is to have the tokens being able to be burned and mint by the bridges. You would say, yeah, okay, I'm not sure I want my token to be minted by a bridge. And that's fair, because bridges do have hacks and they fail. So if I allow my token to be minted and then the bridge is compromised, the bridge will be able to mint my token, and yeah, I become poor, which is not the idea. But in some cases, like bridges should be trusted, and that's what, that's a model that you can try. For instance, for optimism, the bridge is quite safe because if there is some kind of lie or whatever, you can kind of roll back. That's true for multiple solutions. So we just have this ERC merge, which is an interface for token to be minted and burned by bridges. It's a very simple ERC. We just say to a bridge, you should speak to this function and to this function to mint and burn. And on top of that, if you still don't really like the bridges, you can add more protection by adding custom allowance. Like you can say, I'm going to allow this bridge to mint up to this amount. And that's what XRC20 does. XRC20, you probably heard, is like another standard which adds these kind of limits. It works for tokens that are ownable. But yeah, it's also a great solution. All right, so moving on to the last goal, how to maximize simplicity. This is the hardest because it's not a matter of technology. It's a matter of coordination. This is what we are doing with the AEF. And basically, it's trying to identify the core primitives that we are trying to solve, like message passing, like hooks, or like validation. How do we do all these things? How do we standardize the interfaces? And what we want to do is just to try to find the simplest solution that catches the most uses. Like, we don't care about finding the best possible solution, but the one that works the best for now, all right? So it's kind of the famous KXCD comic, where what you will see is that everyone is trying to come up with standards, but there are too many standards, so someone says, okay, I'm gonna come up with the ultimate standard that gathers everyone and like finally solves this issue, and then you end up with more standards. So we are trying to avoid this. We are trying to coordinate the different parties so that this doesn't happen. But yeah, of course, it's not easy. Like, everyone is trying to pull into their own protocol, their own standard. Everyone has built a bridge with an interface, and they want that interface to become the standard. So that's what we are trying to avoid. So what's next? Because message passing is boring. We have been doing this for a lot of time, and sending 10 tokens from one chain to another. You probably saw that example 20 times already in presentation. But we want something like more powerful. So for instance, if I want to say, hey, instead of that, I want to get this token, but this token is not available on this chain. So all the logic of bridging, swapping on the other token, on the other chain, and then going back, that's one of the coolest things you can do, and that you can do with intents, for instance. Intents is basically a way of saying this sort of paradigm, where you go from explicitly calling the functions to explicitly saying intentions. Intents is short for intentions. So it's, I want some explicit, the application will do its ancient dark magic against the black box to basically achieve that, and then we'll return the X, okay? So this is what solvers are trying to do now, a little bit more complex than just sending the liquidity. But of course, you need standards. You need a way of standardizing how the user expresses an intention, how that intention is executed, and finally how it's settled. Because end of the day, you need to prove that the solver had actually completed that intention of moving the tokens, swapping, and going back. And doing that on chain is not easy at all. So you also need kind of standard for that. The most powerful standard, well, the most accepted is this 7683 by Across and Uniswap. You're probably going to see this a lot. And there is also the Open Intent Framework, which the Ethereum Foundation announced after this, which is a set of tools for developer to play around with intents and trying to see what comes out from it. It gives you like UI tools, it gives you scripts for hearing the intents and processing them, and also like the contracts. Yeah, we are here as well. And some open issues, among others, because this is very like the tip of the spear on what's going on now, on the discussions on Ethereum magicians, which is basically the first one is front running of public intentions. I gave the example of I want to swap in a different chain. Okay, if I make that intention public, someone will see that and they will swap before I do because they know the price is going to increase. So they're going to increase the price before I do and they are going to sell afterwards. So that's called a sandwich attack. And that's something that happened with MEV in Ethereum. That's also something that can happen with this kind of cross-chain interactions when you make them public. So we need some way of encrypting the intention or maybe sending the intention to a private mempool. We still don't have a clear answer. Also the liquidity, what I mentioned about solvers needing the liquidity available, that's a huge issue. So how do we solve that? No idea. And finally, verification of complex intents. Like these intents might be very complex, and trying to verify those on chain is not an easy task. You might need very CK magic or whatever. So yeah, if you think of solutions for any of these, you're gonna get the $1 million problem. But this is still boring. Like still like sending the intention of swapping is nothing new. I can do it. Okay, it's nothing like revolutionary. And this is where 7702 comes into the picture. I don't know if you heard about this CIP, but we're going to have an Ethereum upgrade coming in the next month, in April, I think, which is Spectra. Spectra is going to include the CIP 7702, which basically allows you to have a new type of transaction where me as a user will act like a proxy for a contract. So basically, I can interact as if I were a contract. I can interact as if I had logic on myself. Now when you interact, you're an AOI, that you have your private key, you sign, but you just do basic stuff. But then you have another world, which is the world of contracts that cannot initiate transactions. With this, you're going to be able to be as a contract. So with this, you're going to have like very complex and very fun stuff. Not clear exactly what are all the applications that you can unlock with this, so happy to hear from you if you have any ideas. But things like, for instance, I want to bridge 10 ETH, but you have 6 in one chain and 4 in another. So how do we abstract this away? Well, with 7702, we can have logic that does these kind of things, that will like basically get the funds from other chains and send it to one place. So that's pretty crazy. Or things like sending a message batch. So these are a group of messages that needs to be executed in a very specific order and cannot be executed individually. So that's something that you can also unlock with 7702. So yeah. All right, so to wrap up, Interop is what tries to solve the fragmentation problem that we bought after the scalability roadmap of trying to have this non-monolithical vision. We know the goals. We don't have a clear like definition, but I think the goals are good enough. We need a lot of work on technology, especially for message passing, on standards. That's what we are struggling the most, and coordination, trying not to step over each other. And finally, we're going to have some pretty crazy cross-chain things coming with 7702, with intents. So if you have ideas, I think this is a very nice place to look for inspiration. So if you want to work on interoperability, feel free to apply to Wonder. We are always looking for people. So yeah, thank you very much.